I am Jacopo Spalletti. I am CTO and founder of Nephila. We build websites and web applications with Django. I've been working with Django since 2009, and I'm also the author of a few Django applications and co-developer of Django CMS. And these are my contacts. As you can see from my shirt, I'm also a beer enthusiast. So when I'm not coding, you'll likely find me in some pub. And if you want to join me on Saturday on a small pub crawl in the city center, just ping me on Slack. So for some time now, web has evolved in being a much more richer environment. And you don't have anymore the usual request response cycle. Now richness and complexity of web applications have grown a lot. And we have a lot of tools, which is nice. Our little nerd inside us is very happy to have nice tools, new tools to try. But it also brings a lot of complexity. And sometimes build complex application is not fun. There are already a lot of tools, libraries, and whatever in Python and any other languages to build applications, web applications real time. And but for us, it will be fun, more fun to build with Django. And so channels entered a few years ago. It started as a core project from the very start. Now is still maintained by the same team as the whole Django project. And channels is a framework for real-time applications with Django. It obviously handled WEBSOCKETs because it's natural for a web framework, but it's not limited to it. You can have a lot of other protocols like boats, IoT, or whatever you want actually. But in the rest of the talk, I assume WebSockets, which is in the core of channels, so it's more natural to work with it. Channels has gone along two major versions. Channels 2 is just a few weeks old. It changed a lot of things for the best from version 1, which served for almost 3 years. Channels 2 is still not on feature parity with Channels 1. Some features won't enter Channels 2. Some other will likely enter in the future. We will focus on Channels 2 because, yes, it's the current one, and I'll give some comparison with one. But if you are interested in Channel 1, I give a previous version of this talk at Swiss Python Summit in February, and I will give you the link to the previous version. So I want this talk to be very actionable. I want you to show something that you can try yourself. So it's based on a demo application we will see, and then we will go down into the code of this sample application to know how the basic of channel works. So some basic concepts, which are quite a few of them. First thing is that channels is an asynchronous framework to build asynchronous application. And in this, let me simplify this. In this context, for asynchronous, I mean event-driven, okay? So you have events going through and applications reacting to these events and doing things with it. Asynchronous code is more complex to understand because it's not like how us humans basically work with stuff, and so it's a bit more complex to work with, and for this reason, Channels 2 implemented, like say, an interface which basically is synchronous, and all the synchronous part was underneath. Channels 2 instead decided to expose the asynchronous interface. So you have the best of both worlds. You can work in a completely synchronous code. You don't have to know about async.io, but if you want, you can use it. And this is really great because it allows you much more flexibility. And during the development of channels, SGI protocol specification has been designed. Also, SGI comes into versions which are very different from each other. SGI is not tied to channels. It's been designed to be agnostic. And there are other other specifications that implement the SGI. Things like the WSGI protocol of the synchronous Python world. And for this reason, Channels 2 has been designed as an SGI all the way down approach. So every component of Channels is designed as a full SGI application. This means that you can next channel chain together, and you can do you have a lot of control over which part of channels you are going to use and how you are going to use it. Based on SGI specification, you have the protocol server, which implements the SGI interface. This is a component that that sits behind the clients and the rest of channels and the application itself. So every protocol server is designed for a set of protocols, not necessarily a single protocol, but a set. Like for Daphne is the reference implementation and is designed to handle HTTP and WebSockets. You can implement your own protocol server for whatever protocol you want, actually. And behind the protocol server sits the routing, because as projects will likely have more than one application, you want to direct the connection to the different parts of channels. So it maps incoming messages to the different consumers. Consumers are the applications, basically, you are going to write. Routing especially is written as a set of SGI applications, so you can connect them in very different ways to achieve whatever you want to achieve. And this brings much more flexibility in terms of what kind of how you structure your application and what kind of protocols you can support. The major visible difference between channel 1 and channel 2 is the fact that you have the scope, which basically resembles the request in the Django world, as all the connection information are stored in the scope. But due to the socket nature, the scope is persistent because the connection is persistent. So it maps the connection to the application instance. The channel, which gives the name to channels, it's been actually a bit demoted since the version 1, because before it was basically the connection between the protocol server and all the rest. Now the protocol server is directly connected to the routing and the consumer. Channel is just the IPC mechanism of channels. So consumers talk to each other by using the channel. It's still a first in, first out, at most once queue. So you can build a queue system on channels. You can use channels as a queue system, but be aware that it's most once. So delivery of the message is not guaranteed, which is a decision based on a few trade-offs. Salary, for example, is at least once. So you are guaranteed that messages are delivered. And then there is the main concept, the main abstraction of channels, which are the consumers and are really your SGI app you are going to write and where the stuff happens, so to speak. Each connection is mapped to a consumer instance, and whatever event happens on that connection will be delivered to the consumer, which must implement methods to handle these events. And we will see some examples later. Events are triggered during a scope. They can be generated outside in the network, like client connecting or sending messages or whatever. Or they can be triggered by consumers or anyway happening on the channel. And consumers are consumers because they consume events. WebSockets is not really, doesn't mean 100% JavaScript, but you will mostly likely write JavaScript client for WebSockets. And so channels has a lot of JavaScript, which is meant to simplify the interaction with WebSockets. Last but not least, groups are very important because they allow you to send messages to different consumers, staying connected to the same channel. You have to broadcast messages on the same channel. And, allows you to address messages to just a set of consumers. A brief overview of what has changed between channels 1 and channels 2. As I said before, channels 2 exposes the async IO interface. It's based on async IO and completely exposes the async interface. You can write async consumers. This means also that is Python 3 only, and Python 3 and up only. The other big change is that now, thanks to this decision, basically, the protocol server runs in the same process as Django and as the consumer. So you don't have the need for the channels anymore for a communication system. And there is no more separated container worker, which means the setup is a bit simpler. And this allows to introduce middlewares, which basically works the same as the Django ones, as the WSGI ones, actually, and also allows the SGI all the way down approach. Upgrading is not straightforward because channel has changed completely. Consumers are now stateful. Before was stateless, so they're completely different. And you have a much more flexible way to create during the lifetime of your consumers. So the upgrade will need some rewrite. Especially the routing has changed completely, but it's more simpler. Consumers are completely different, but the interface is not that different, so it's easy to port code from one to another. Test, you have to rewrite them from scratch completely. Everything has changed there. If you are interested in some differences between channels 1 and channels 2, you can check these 2 branches of the sample application we will show we will see in a minute. So enough theory. This is an example application. It's with the 2 versions of channels. And let's call it poor folks Google Docs, because it can count active users. It can check the concurrency when multiple users open the same document. And so, as I don't want to sacrifice kittens to the dive-lemma god, I recorded a video. Yes. So you have here 2 users, Leela and Fry. Leela is already logged in, and she's alone. Fry's enter, and then I hope you can see the users are counted. And this green labels tells that no one has opened a document. Now Fry enters a document, and Leela label turns yellow with a Fry name there. If Fry opens the document for writing, the labels change to red, again with Fry's name in it. Leela opens the document again, and the Fry's version, the Fry's document turns red again. Fry's goes out, and Leela labels goes green. So it's very simple. It was readable from afar, but it will be probably simpler to follow when I'll upload the slides. So that's very stupid application, and the code is even more stupid, but yeah, it allows you to show a few things. So these are the 3 parts of channels you are going to configure and work and write. Channel layers, routing, and consumers. Channel layers. Channel layers are is the configuration of the channels. So the storage, basically, of the messages. And it's just this. Channels support currently 2 storages, the Redis and the in-memory. In-memory is basically for testing, for run server, not for production. And so the official one is Redis. And then the routing. The routing is almost similar to the Django one, but it's more complex because all these are SDI application nested one to another. Now let's see more in details. You have middlewares, which are this one. Middlewares, as I said, works basically like the WSGI ones, so allows you to put things on the scope. Channels ships with a few middlewares, which basically allows you to bring the user information into channels from during the protocol upgrade between HTTP and WebSockets. And then there are the routers. Here shown are two routers. The protocol type router, which maps the protocol, WebSockets for in this example, to the rest, to the inner layers. And you can add as many protocols as you want here. And protocol router is the one in charge of routing the messages to the different protocols. Currently, you can write your own protocol, basically, and implement in the SDI specification and do whatever you want. That's URL router are specific for WebSockets and are, as you can see from here, are based on path. This is the same path function as Django. And here, you can see they are nested. Oh, important thing, routing is forever. So a connection is routed when it's established. Then the link is, is active for the rest of the connection lifetime. This means also that the fewer consumers you are going to write, the better the performance will be, because you have less things, less objects in memory and less connections open. So if you can do a multi-purpose consumer that can handle all the different actions required by your application. And that's, oh, sorry. That's the routing of a single application. It's basically this, this object here. And this is really just Django URL-conf. You have the path here with, you can use the Django 2.0 syntax, and then these are the consumers. And consumers. Consumers are where stuff happens, so are the real core of your application and basically the code you are going to write. This is a very generic consumer which does nothing, basically. It's just, but it exposes the WebSocket consumer because every protocol has its own default events. So by default, a WebSocket consumer exposes these three methods, which matches the three events: connection, disconnection, and receive. Message is received. Here you can declare the groups, the application, the WebSocket listen to or respond to. And then you are going to write your own event manager, so to speak, but just methods. And what I mean? I mean that this is a very stupid consumer. When a user connects, it's just send, and we will go into details later of all this whole thing, but the idea is that it sends this message to this group with the type, and then some kind of payload. This event must match the method name in the consumer's listening, basically, on this group. And then this method does something with the event, with the incoming event, which means whatever. In this case, just send back to the connected client the value. One important thing to understand is that this method and this one happens in different consumers, different instances. Can happen in different classes, because you can have multiple consumer classes on the same group and responding to the same event. So this is a message that one instance sent to all the other instances, basically complying with the same API. That's basically the idea. And then each consumer can react in a different way. For example, we can have another consumer on the same group implementing this method, which doesn't send this message when the user connects and just listen for the incoming messages and does something. I don't know, maybe counting the user in the database for some reason. And now let's see more in detail what the application does. Let me, okay, yes. This is the consumer that counts the user and informs the clients how many people are connected. So when incoming connection comes, we basically increment the user in some way. The demo application does in a very bad way, and don't do that because it's basically you have race condition everywhere, but yeah, it's just a demo. And then it sends back the number of connected users with by using this call we will see in details. Again, we have the users count method, which matches the message name, which sends back the message. On disconnect, we obviously decrement the number of users, and we will notify all the users. Again, this message is sent to all the connected clients. So even when our user is disconnected, doesn't have any sense to send back to it the number of connected users, but all the other clients needs to be notified. This is the very simple front-end code. Look, I wrote JavaScript code. I think it's the first talk in which I show some JavaScript code. A modern one, see, arrow function. And so this is basically just a tiny wrapper on WebSockets. You just connect to some path, to the path representing your consumers. You listen to the event, to the incoming events, and if you have an event with the right data in it, you just change the DOM and just put the number of users there. And a bit more complex feature, concurrency monitor. In this case, we want to check exactly the state of each client on each document, so it's a bit more complex. We also want to notify the number of the status of the document. So in this case, the groups are not a property like, not an attribute like in the previous version of the consumer, but is a property. And this one, this is static. This is just a constant, basically. But this is the slug of the current document, which is captured by the path in the routing. And so every document a consumer will register on a different group. So all the clients connected to different documents will receive different messages. Again, on connect, we count the user. We get the name of the user. We also check the phase, what in this demo application is called phase. So if it's opened for reading or for editing. Then I call the super because we need to, on connect, we need to send back an accept message to the clients, and channels will do this for us. And then again, we will send the message back. But to a different events, basically different type, and you have a different method to track it. Now, let's see what this means. Basically, this is the core of channel. Okay, the rest is just sort of structure. So, async to sync is the method, an helper method that channels provide to send, to execute functions, asynchronous function from a synchronous environment. The opposite also exists. In this case, we call the group send, which is a function that sends a message to a group, as the name suggests, on all the consumers connected to the same channel layer. And this function is asynchronous, and that's the reason why we need to wrap on using this async to sync. In this case, in this example, we use the slug as the group name. but this is just a string representing the group you want to send the message to. And then you have the message itself, which is this one. The only mandatory argument, key is type, which must map some kind of method on the consumers listening on the same group. And then actually I call this message, but can be whatever you want. The rest of keys are up to you. You can even use binary data here according to the class, to the consumer class you are using, because you have quite a stack of classes to use depending on how deep in the stack you want to work. In this case, I just used JSON WebSocket consumer, which handled the serialization to JSON deserialization, etc., and want to deal with such details. Again, I'm going to, because the event is as type document status, the document status method is going to be called. The documents list works exactly the same way, basically. We just don't count the users because we have the number of connected users in the more generic consumer. Here, we just get the status of all the documents and we send using the same event type. Note that the group here is different. You don't have self/slag. So even if the method has the same name, is a different event basically because is on a different group. Front-end code is quite straightforward. Again, I hid some implementation details which are not really interesting. You connect, you listen for the data, and do something basically. I just change the color of the label, etc. One of the most interesting feature of channels, which is easier in channels 2 than in channel 1, is that you can send messages from outside channels from your Django code to the channel itself, to the channel-enabled application, or to the consumer, basically. In this case, in the save method of a model, I just used exactly the same function, async to sync, because we are in Django, so we are in a synchronous environment. I send this document saved type event with the message document saved, and then have a consumer here, just listen for the same message on self.slag group, and this method can do something like sending a browser notification to the users, which is left as exercise to the reader. Some FAQ. So I will tell in advance something that you might curious of: performances. With regards to other asynchronous frameworks, channels is a bit more is not as performant maybe, but the Djangonauts loves maintainability and ease of use and expressiveness more than raw performances. Channels 2 is much more performant than channels 1 because there is no more the serialization and deserialization between the protocol server and the consumers. Deployments. There are two ways to deploy channels 2, which is a bit simpler. You can deploy by completely replacing the WSGI servers, and you just use Daphne, and you basically can use exactly like you deploy the normal Django, or you can have two servers, basically the usual WSGI server serving Django and your usual code base, and Daphne handling the WebSockets. In this case, you have to separate the path because on the web server side, you have to route the WebSockets to Daphne. Like, I don't know, -ws is the path of that is handled by Daphne. So in the end, channels make async much easier, especially for Djangonauts, which are really more synchronous people. or at least used to work with Synchronous API. And it provides full access to the Django API, so you can do whatever you want. You can interact with database, with models, with forms, with whatever it is. It's first-class citizen in the Django world, so you can do whatever you want. Thank you so much for attending. I hope I delivered a few information to you. This is the link on the Channels 1 version of the talk. And we are hiring, so if you want to work on an interesting project, very different, you'll likely not work on two same projects during your career, probably. And yeah, come to me and talk to me, and we are hiring. Time for question, I guess. Question, anybody? He's coming.
Can you please give a couple of notes how to scale channels application?
Sorry?
How to scale, about scalability.
I don't have raw numbers because I've used right now in low concurrency environments. But you can easily scale because you can add more Daphne on front, more workers at the back. So it's basically, you can easily containerize it and spawn more things. And as long as you can route the channels interface, you can take care of everything. Any more questions? Okay. Okay. Good.
No more question? Okay, thank you, Jacopo, for your talk.
Thank you.